We've added a new option inside our edge deburring recognition called dynamic cutting diameter. By using the dynamic cutting diameter, you can change while you're cutting the cutting diameter of the tool that is being used. By doing this, you're actually saving some wear and tear on that particular edge of the tool by not always cutting on the same edge. Let's take a look at how this works. I'm going to choose a geometry. In this particular case, to make it easier on us, I'm just going to choose one face. So I'll choose the option of faces, and I'll just pick the top face. I'll accept that, and then I'll choose my chamfer mill. In this particular case, I will be using a 10 millimeter chamfer mill. Now, the levels, I'm just going to give it a 0.5 millimeter of depth for the chamfer. And now let's go to our technology field. You'll note we have the option called dynamic cutting diameter. In this case, I can put my minimum diameter and my maximum diameter. The minimum diameter can be the minimum up to the minimum diameter of the tool itself, while the maximum can be up to the maximum diameter of the tool. Let's just say my minimum diameter in this particular case that I want to use on the tool is going to be 2 millimeters. And since I have a 10 millimeter chamfer mill, I'm going to go up to 8 millimeters. Now, let's just do a quick save and calculate. And we'll take a look at the actual tool pass. You'll note that as it's going around, you'll see that the tool goes in, and also look at the Z level. Right now, it's at 1.5. But if I continue on, you'll see that it is constantly changing as we're going around. It goes down and up. If we take a look at the side view of the part, you can see that the tool path is gradually going further down. Looking at it from a different side, you can also see that it goes even further down over here. If it meets an area in the middle where it may actually gouge, it actually jumps back up to its minimum diameter, and then when it passes that area, it goes back down. Always creating the chamfer exactly the way it should be, and changing the diameter as it works around. Let's just take a quick look also in Solid Verify, and you can see the actual tool pass is going to be exactly what we need, going further down as it goes around the part, but the size of the chamfer will always remain the same around the entire part, no matter what diameter you're using of the tool.